In this video, we're going to talk about how to get rid of paired edges, this paired edges condition, because we talked about how to reduce ZOE to Hamiltonian cycles that have this paired edges condition where I have to use exactly one edge in each edge pair. But we didn't talk about how to just do Hamiltonian cycles, and I'm much more interested in just plain old Hamiltonian cycles than I am in edge pairs. So let's go ahead and see if I can take an edge pair problem and turn it into something that would just have to do with Hamiltonian cycles. If I can take this edge pair and say that, hey, if I have a Hamiltonian cycle that has this edge pair, that's really this interchangeable with having a Hamiltonian cycle period with a certain type of structure. And how we're going to do that is I'm going to take each edge pair and I'm going to turn it into, I'm basically going to add 4 paths between the edges in that pair. That's going to add a bunch of vertices along those edges, and then I'm also going to put a vertex in the middle of each of those paths. And what we're going to show is that if I have a Hamiltonian cycle that uses this structure, then it must use either the edges A1 and A2, or it must use the edges B1 and B2. And essentially using the edges A1 and A2 would correspond directly to using the edge A, and using the edges B1 and B2 would correspond directly to using the edge B. And what we're saying is I have to either use this or this, but not both. So let's go ahead and see what can happen. So let's say I have a Hamiltonian cycle, it's doing its own thing, and then it gets here. And I need to get to this vertex eventually, so I probably need to use this edge. Well, let's go ahead and say that I use the edge A1. If I don't use, let's actually start with the case where I don't use any of these edges, A1, A2, B1, or B2, then I clearly have no way to get to any of these vertices. So I need to use one of them. And let's go ahead and say that it's A1. So we'll say I go use A1. If I go on to this edge down here, then I've missed the boat on ever using this vertex, because I'm going to need to go into this vertex at some point, and then I wouldn't have anywhere to go afterwards because I've already used this vertex. So in order to get to this central vertex, I'm going to need to do it right now. And then I go out this way, and I'm going to tell you that the correct thing to do is to kind of snake around. But let's say that I decided to go up to B instead. Okay, so then let's say I did that. That was fun. And then I came back around to maybe we'll say B at this point, and I want to make sure that I get all these middle vertices. So by the same logic, I would still need to use this. But now I don't have the choice to just go back down to A2. I need to keep going and snaking around to get the next middle vertex. And then I need to keep snaking around to get this next middle vertex. And oh no, once I get here, I'm stuck. I have nowhere else to go because I've already used both those vertices. So I can't use a Hamiltonian cycle where I do a little, I go here and then I just kind of leave and then try to get the rest later. I need to continue snaking down to the next vertex. And once I'm here, I have no choice but to go here. And once I'm here, I have no choice but to go here. And once I'm here, I have no choice but to use the edge A1 and A2. And I haven't used the edges B1 and B2. And I certainly couldn't, because if I eventually I will get to the edge B2, because it is, or to the vertex here, not the edge. I'll eventually get to this vertex, because it is a Hamiltonian cycle. I need to use everything. But once I get here, I'm not allowed to use the edge B2 because I've already used the other vertex on the end of that edge. So what we see is that when I eventually get to B2, I'm going to need to figure out somewhere else to go in my Hamiltonian cycle. So we've shown that, first of all, I do have to use at least one of these. And then if I use A1, and I want to get a Hamiltonian cycle, I'll be forced to also use A2 and also not use B1 or B2. So we've correctly mimicked that structure. So I can take the condition of having a paired edges A and B and replace that with this structure, which with no additional requirements on my Hamiltonian cycle will require that I either use the edges A1 and A2 or the edges B1 and B2. And that's not anything that I've imposed on the problem. That is something that's just by nature of how you draw Hamiltonian cycles in this case. So we've officially gotten rid of the paired edges problem. So what I want to do next is show what this would look like in the graph, and I'm going to do that by getting rid of all but one of these paired edges, because if I tried to do all of them, the graph would be atrocious. So what I'm going to do is I'm going to take each of these paired edges and then replace them as described here. So I need to have a paired edge from 1 to 8, or I have a paired edge from 1 to 8, which means that I need to take the edge 1 and the edge 8 and then add these 4 little paths. So let's add those. And you'll see shortly why I'm restricting, why I'm not going to do all of them. Okay, so I'm adding those 4 paths. Notice I'm drawing these vertices specifically. There's also a bunch of vertices now here and here. I'm not going to draw all of those specifically. So that takes care of the edge pair 1, 8. Then I'd also have the edge pair 1, 6 and 1, 5. I don't think I can fit 12 edges coming out from here because I do need to draw 4 more edges. So that's fun. So I'm going to just do 1, 5. I'm going to have a harder time fitting them on the edge 5 than I am on the edge 1. And there we go. There we go. Put some vertices in those. So we took care of that edge pair. I could theoretically have done the same thing with the edge pair 1, 6, but I don't have room, so I'm not going to. And then we're also going to do the same thing with the edge pair 3, 7. And as you see, this graph looks really, really messy. Ooh, I'm going to have a hard time trying to make it not cross through the vertices that look like they have vertices on them. Okay, so there's our graph. We still have one edge pair, but again, that was just because I didn't have room on my picture. So let's make sure that this does what we think it does. We've pretty much justified that this should be fine based on this explanation, but let's go ahead and see if that actually works. So let's start by doing a bad Hamiltonian cycle. I want to kind of show myself that if I try to use what used to be edge A0, that I'm going to run into a problem where I can't do a Hamiltonian cycle. So let's go ahead and try it. Based on what we said earlier, the only way I'm going to be able to do a Hamiltonian cycle using this edge here is to do a little snaky thing. So let's do our snaky thing. And what you might notice is that we've essentially canceled out the edge 8 from consideration for the future. Okay. So now I use this edge. And we also just said that when I use this edge, I also am going to need to do a snaky thing to get all these vertices. That's the only way I'll be able to draw a Hamiltonian path with this structure involved. And what you might notice is that now I've actually canceled out the edge 5 too. Just because I don't need it, let's go ahead and set b equal to 1, so I don't need to do all that snaking around again. And what we'll see is that when I get here, I'm stuck, because I've already used that vertex, so there's nowhere for me to go here. So, that was bad. I wasn't able to get my Hamiltonian cycle, which is exactly what I wanted. I knew that my solution was supposed to be a equals 1, b equals 0, so the fact that I got a equals since the fact that I couldn't do a Hamiltonian cycle that way fits what I expected. So let's go ahead and now do that, doing it the smart way, doing the solution I know works. So I'm going to use the edge A1, and this might give me a little bit of fear, because I might say to myself, uh-oh, I have all these vertices that I placed along edge A0. I really hope those get taken up in my Hamiltonian cycle. And the good news is they will. So we go ahead and continue on. I'm going to use B here, B equals 0, which, oh, don't do that, which will then take me along this little snaky route. Again, that's the only way. We proved earlier that that's the only way I'll possibly be able to get this Hamiltonian cycle to work out, is by doing that snaking route. And we notice that we've used all the vertices on this edge, and I've also kind of eliminated the possibility to use the edge proper itself. So we've used all the things on the inside, but I won't be able to get the edges on the outside. Okay, and then I get to this edge, and oh look, I do my snaky thing, and you'll notice that as I do my snaky thing, I'm going to use up the vertices that I was worried about earlier on that edge 1. So that's a good thing. I'll use this edge. That's a paired edge thing. So I still have one edge pair there. Yeah, so technically that would have been another snaky thing. I just didn't have room. And then we get to do another snaky thing here. And voila, there's my Hamiltonian cycle. So we've now officially taken this matrix equation, which originally looked something like this. And we turned it into that graph. And we showed that if you can find a Hamiltonian cycle on this graph, then that gives you a solution to this problem. We also show that if there's not a Hamiltonian cycle here, so basically, if we weren't able to find a Hamiltonian cycle, that would mean that there's no solution which satisfies this equation. All that said, this shows you how to translate a 0-1 equation problem into a Hamiltonian cycle problem. And if you can find a Hamiltonian cycle, that's a solution to your equation. If you can't find a Hamiltonian cycle, then that would mean that there's no solution to this equation. And there you go. So that's how we translate the 0-1 equation problem into the Hamiltonian cycle problem.